This is a video about chemical bonds. When two things bond together, the nucleus of one atom is attracted to the valence electrons of the other atom. Um, why do atoms chemically bond in the first place? It's just to become more stable. They want to be overall less energetic. And that leads us to something called bond energy. So bond energy, this is kind of showing you the distance between like hydrogen atoms in picometers and the potential energy. And you can see down here is going to be where the lowest amount of energy is, and this would be the most ideal and where the chemical bond is actually formed. Up here, the two nuclei are too close together. Here they're a little bit too far, and here they're completely separated. So this is just showing you that things bond in order to be more stable and have less energy. So a covalent bond is when the electrons, the valence electrons, some are being shared between two atoms, and the orbitals actually overlap one another. And there's two types of covalent bonds, and you learned about this in the POGO. There is we want to use the values here that I'm giving you and that I gave you in the POGO, not what the textbook says. So different texts will give you different breakdowns of when something is nonpolar, polar, or ionic, and these are the values we're going to use. So when I look at the electronegativity difference and I subtract two elements from one another, if I get something between 0 and 0.4 of a difference, then we consider that a nonpolar covalent bond, which means that they're sharing the electrons between them equally or almost equally. And then when they're sharing again, I gotta move my picture, it's in the way, this way. Oh, can't get me out of there. All right. So if their electronegativity difference between them is somewhere between 0.5 and 2.0, then they're still considered covalent, so they're sharing, and you can see in the picture they're sharing the blanket. But one of the atoms, the one with the higher electronegativity, is going to pull those electrons closer to itself. And then we have the extreme case of this, which is when we have an ionic bond. I can't get it. There we go. So an ionic bond is when, and this is typically between a metal and a nonmetal, when the electronegativity difference is so big, 2.1 or greater, that the one with the higher electronegativity will take the electrons or the blanket from the other one. So just to review, and this is kind of a diagram showing you, again, with kind of electron clouds, where the blue is going to be the most dense, where your most of your electrons are found, and the red would be where there's less electrons found. So this is a diatomic molecule of chlorine, and chlorine, because they both have exactly the same electron configuration, they're going to share perfectly equally. So the difference between them is 0, so they fall into this nonpolar 0 to 0.4 difference. This one here is going to be a polar covalent. Hydrogen's electronegativity is 2.1. Chlorine is 3.0. So the difference between them is 1.9. Actually not. The difference is 0.9, sorry. So the 0.9 difference would fall into that 0.5 to 2.0 range. So you can see that the chlorine with the higher electronegativity is pulling the electrons towards itself, away from the element with the lower electronegativity. And then here's an example of an ionic bond. Chlorine's electronegativity is 3.0. Sodium is 0.9. So the difference between them is 2.1. And that falls in the range of 2.1 or greater.